All right, so today we're diving into something that sounds pretty complex.
It does, doesn't it?
It really does, but
Yeah.
hopefully we're going to make it,
Break it down.
yeah, break down, make it accessible and
Fun.
Exactly.
Sounds a little intimidating at first. Natural language reinforcement learning.
It does. It kind of sounds like we're going to be teaching robots to like write poetry,
Yeah.
but it's actually, I think, a little bit cooler than that.
Yeah, I think it's an area of AI research that really does sort of blur the lines between science fiction and what's possible.
Absolutely. And we're going to be using this research paper as our guide today. It's called Natural Language Reinforcement Learning, and it's by Shidong Feng and a whole team of researchers from a bunch of different universities. And I think our goal today should be to try to understand not just what NLRL is, but why it's causing such a buzz in the AI community.
Yeah, I think that's a great goal.
Yeah. So by the time you're done listening to this deep dive, you should be walking away understanding how NLRL could change the way we train and interact with AI. You know, everything from your friendly neighborhood chatbot to maybe even something as complex as self-driving cars.
Right. Yeah, the applications are really far-reaching. I think one thing that might be helpful for folks is to kind of revisit just the foundation of traditional reinforcement learning and sort of see where it falls short and where NLRL comes in.
Yeah, that's a great idea. So imagine you're like teaching a dog a new trick, right?
Okay.
So like you give the dog a treat when they do the trick correctly.
Standard reinforcement learning.
Exactly. So that's kind of how traditional reinforcement learning works.
Right.
The AI is basically exploring, like a game or some kind of environment.
And it's trying things out.
Trying things out, and it's getting
Yeah.
feedback in the form of like points or rewards. So over time, it figures out like, oh, okay, if I do this, I get more points, and that must be the right thing to do.
Right, exactly. And the thing is, like with a dog, you're using treats, but you're also probably giving it some kind of verbal feedback.
Yeah, good boy.
Good boy.
Yeah.
No bad dog, all of that. Whereas in traditional reinforcement learning, it's often just that score, no tips, no explanations, just the numbers going up or going down.
So it's like trying to learn how to play a video game from a coach who like only speaks in thumbs up or thumbs down, like not very helpful.
Yeah, exactly. Exactly. So it can be effective,
Yeah.
but it needs massive amounts of data to learn. And it can be really hard to understand why the AI is making the decisions it's making.
Right. It's like a black box.
Totally a black box.
Yeah. So that's kind of where NLRL comes in, right?
Yeah.
It's trying to solve that communication problem.
Exactly. Yeah. So imagine if you could talk to the AI during training and give it, richer feedback, more like what we would give to another human, like, good job, you're on the right track. Or, nope, try again, that was a bad move. That's the basic idea here.
Okay, that makes a lot more sense. It's like we're taking something that's been very numerical, very abstract, and we're grounding it in language, which is like how we as humans understand the world.
Exactly. And what's really cool is that this paper provides a framework for actually doing that, translating those traditional RL concepts like policy and value function into their natural language equivalents.
So instead of numbers and equations, we're giving the AI instructions and evaluations in like plain English.
Precisely. So, for example, instead of a numerical value function, you might have an LLM say, this is a risky move, but the potential payoff is high.
I mean, that's so much more understandable than like a string of numbers and symbols.
Exactly. And I think it's that understandability that's key because it allows us to not only train AI more effectively, but also to understand how it's learning and to potentially even, intervene and guide the process in a more meaningful way.
Yeah, that makes sense. And I think it also speaks to this idea that we're kind of like, I don't know, democratizing AI in a way, right? Like making it more accessible to people who maybe don't have a PhD in mathematics.
Okay.
So are we basically tapping into the vast knowledge that LLMs already have about the world, right? Because they've been trained on all this text, so they already understand language, they understand concepts, they even understand relationships between things.
That's exactly right. So all of that knowledge that's baked into these LLMs becomes incredibly valuable when we're talking about NLRL. Because now instead of starting from scratch, we're starting with an AI that already has a pretty good understanding of the world.
That's really cool. So it's like giving the AI a head start. It's like, okay, you already know all this stuff about language in the world. Now let's apply that to learning new tasks and solving problems.
Exactly, yeah. So instead of just having to learn from raw data, it can draw on this wealth of pre-existing knowledge, and that's what makes it so powerful.
I'm starting to see why people are so excited about this, but, this all sounds very theoretical. Like, how do we actually use LLMs to make this work in practice? Like, how do we actually build systems that can do NLRL?
Right, yeah, I think that's a great question, and this is where the paper gets really interesting. So it proposes using LLMs to actually implement each component of an NLRL system. So you can have one LLM that's acting as the policy,
Hmm.
which is deciding what actions to take, another one that's the value function, evaluating those actions, and even LLMs that are acting as operators, which are collecting feedback and using it to update the policy over time.
So we're like building a team of LLMs that can talk to each other
Exactly. It's this whole ecosystem.
and learn from each other all through
It's
language.
really cool,
Yeah,
right?
it's like, I mean, it's a pretty radical shift from how we've traditionally thought about AI.
Totally. Yeah, it's moving away from this idea of AI as just a number crunching machine
Yeah.
and more towards this idea of AI as something that can actually understand and interact with the world through language, which is so much closer to how we as humans experience the world.
Absolutely. And I think, we've talked a lot about theory, but I want to get to the practical stuff. Because this paper is not just theory, it actually shows how NLRL is already being used to improve the performance of LLMs in solving problems. So they've actually run experiments using games as like a test bed.
Yeah, exactly. And the results are really promising.
Okay, so tell me about these experiments. Like, what are the highlights? What did they do?
One experiment involved teaching an LLM to navigate a maze.
Okay.
So using NLRL, they gave the LLM textual feedback at each step.
Like you're getting warmer, you're getting colder.
Exactly. Things like you're getting closer or dead end, try a different path.
So it's like the LLM is like playing a game of hot and cold, but with language instead of temperature.
Yeah, exactly. And what's fascinating is that the LLMs trained with NLRL actually learned to navigate the mazes more efficiently than those trained with traditional RL methods. They made fewer errors and they found the goal more quickly.
Wow, that's really cool. But mazes seem kind of simple.
Sure.
Like, can NLRL handle more like strategic, complex tasks?
Yeah, that's a good question. And they tested that too using a board game called Breakthrough. Have you ever played that?
I have not.
Okay, so it's kind of like chess. It's a two-player strategy game.
Okay.
And they used NLRL to train an LLM to evaluate different board positions. So it's almost like, like a human expert commentator would look at the board and say, oh, this player's in a really strong position, or this is a risky move.
That seems incredibly difficult. Like, how do you even determine if the LLM is doing a good job? Like, evaluating a board position in a game like that seems like incredibly complex.
Yeah, it's a real challenge. And they used a clever technique called Monte Carlo simulation to estimate the probability of winning from each position. And so that essentially gives you a kind of ground truth to compare against the LLM's evaluation.
Okay, so they basically had like a supercomputer crunching probabilities to see how well the LLM stacked up.
Exactly. It's a pretty tough test.
That's amazing.
And the results were really promising. The LLM trained with NLRL performed remarkably well, which I think really demonstrates that this approach can be used to teach AI systems complex tasks that require, strategic thinking and understanding of like long-term consequences.
That's incredible. Okay, so what about like a classic game like Tic-Tac-Toe? Did they try that too?
They did, and this one is particularly intriguing because they used NLRL to create what they call a natural language actor-critic system.
Hmm.
And this system learns to play tic-tac-toe purely through language interaction and feedback.
So it's like playing against an AI opponent that you can actually have a conversation with during the game.
Exactly. And what's really interesting about this example is that it showcases NLRL working in a model-free setting. So the system doesn't have access to the game's rules, just like a human learning through trial and error.
Oh, wow.
So it's really learning by doing and by receiving feedback in natural language.
Okay, I'm starting to see the real potential here. Like, it's not just about, like, playing games better. It's about creating AI systems that can learn and adapt in ways that are much closer to how we as humans learn.
Exactly. And I think that's what makes this research so exciting. It's pushing the boundaries of what we thought was possible with AI and opening up a whole new set of possibilities for how we can interact with and benefit from these systems.
Absolutely. And I think, we're starting to see the potential, but I'm also curious about, like, where does this all fit into the future of AI? Like, what are some of the bigger implications of this research?
That's the big question, isn't it? Like, if we zoom out and look at the bigger picture, I think NLRL has the potential to revolutionize how we train and interact with AI, leading to systems that are more efficient, more explainable, and more adaptable to new situations.
So AI that's not only smarter, but also easier to understand and work with?
Exactly. And that's really important because as AI becomes more integrated into our lives, it's essential that we can understand how it works and that we can trust its decisions.
Absolutely. So that's like a huge step towards like, building trust between humans and AI, which is something that I think a lot of people are like, you know, rightly concerned about.
Right. And it's not just about trust. It's also about making AI more accessible to a wider range of people.
Yeah,
Because if you need a PhD in computer science to understand how an AI works, then it's only going to be accessible to a very small group of people.
that's a good point. But with NLRL, because it's grounded in language, it has the potential to make AI more intuitive and understandable for everyone.
Exactly. And I think that's really exciting because it means that more people can be involved in shaping the future of AI and ensuring that it's used for good.
Okay, so we've kind of set the stage. We've talked about like what NLRL is, why it's important, how it works at a high level.
Yeah.
But I think in the next part of our deep dive, we should really get into the nitty-gritty.
Yeah, let's get into the details.
Let's get into the details of like how NLRL is being implemented, and explore some of the potential applications that like have us most excited, because I think there's a lot to unpack there.
There is, and I think what's really cool is that NLRL is already being used in some really interesting and unexpected ways, and we're
Yeah.
just scratching the surface of what's possible.
Yeah.
So before we jump to this part, we were discussing all the potential that NLRL has, how it could potentially revolutionize how we interact with and even train AI.
Yeah, and we even started touching on how this could lead to AI that like learns a lot more like us, like using language as its primary tool.
Exactly.
But I want to dig into the practical stuff a little bit more, like
Yeah.
we talked about how LLMs can actually be used to implement those different components of NLRL.
Right.
Can you walk us through how that works?
Yeah, absolutely. So um, you might remember that we talked about how LLMs can take on different roles in this whole system. So they can act as the policy or the value function or even the operators that kind of like drive the learning process.
Yeah.
So let's kind of break each of those down and see how an LLM brings that to life.
Okay, so let's start with policy. And just remind me, that's basically like the AI strategy for choosing what actions to take.
Exactly. Yeah. So in a given situation, what's the AI going to do?
Right.
And in traditional RL, that's represented by like a complex mathematical function. But with NLRL, we could use an LLM to actually represent that as a set of, language-based instructions or rules.
Okay.
So, for example, in a chess game, the policy might be something like, if the opponent's queen is vulnerable, prioritize capturing it.
So instead of just like crunching numbers, the LLM is like actually reasoning about the situation and making decisions based on these like kind of like understandable human-like rules.
Yeah, exactly. And that's where the power of these LLMs really shines because they could process information, they can understand the context, and generate these responses that are like much closer to how we think.
Yeah, that's pretty amazing. So what about like the value function? How do LLMs handle that?
Right. So the value function is all about, evaluating how good a particular state or action is.
Right.
So in traditional RL, that's usually a number. But with NLRL, we can actually use an LLM to provide that evaluation using language.
Oh, interesting.
So instead of just getting a score, you might get something like, this move gives you control of the center of the board, which is a strategically strong position, or something like that.
Oh, wow. So instead of just spitting out a number, it's giving us this much richer, more nuanced understanding.
Exactly. And I think that's so valuable
Yeah.
because it helps us to see, why the AI is making the decisions that it's making.
Yeah, that's such a big step towards like AI transparency,
Absolutely.
being able to actually see into the AI's mind a
Yeah,
little bit.
exactly. Yeah.
Okay, so what about those operators we talked about before?
Right.
What do they do, and how do LLMs handle that role?
Yeah, so the operators are kind of like the behind-the-scenes workers.
Okay.
They're collecting feedback from the environment, they're analyzing it,
Right.
and they're using it to actually update that policy and that value function.
Okay.
And guess what? LLMs can do this too.
Wait, really?
Yeah.
So we're talking about LLMs that can learn from experience,
Yeah.
adapt their strategies, even like teach themselves new things.
Yeah.
All through language.
Exactly. Yeah. I mean, this is where it starts to get really revolutionary because we're moving beyond AI systems that are simply programmed to do a specific task.
Right.
We're talking about systems that can learn and evolve on their own,
Yeah.
using language as this like bridge between their internal world and, the external environment.
That is so cool. Okay, so I'm really wrapping my head around this, but I'm also curious, like, how do we actually train these LLMs to perform all these different roles? Like, do we need those like massive data sets that we do with traditional machine learning?
Right. That's That's another exciting aspect of this because it doesn't always require those massive data sets.
Oh, just
So the paper actually outlines different approaches for training LLMs within this NLRL framework.
okay. Can you give us some examples? Like, I'm really curious about how this training process works.
Yeah, so one approach they discuss is what they call language GPI boosting,
Okay,
which stands for Generalized Policy Iteration.
got it.
It's a mouthful, but basically it's a way to use prompting
Okay,
to iteratively improve the LLM's performance
yeah.
as both a critic and a policymaker.
So it's almost like a coach
Yeah.
that's like guiding the LLM, giving it challenges and feedback to help it learn and grow.
That's a great analogy, yeah. And what's really cool is that this can be done purely through prompting.
Oh,
So
wow.
you don't need to go back and explicitly retrain the LLM on new data.
Okay.
You're leveraging what it already knows and its abilities.
That's incredible. It seems like NLRL is opening up this like whole new toolbox
Yeah, I think so.
for AI development. But are there any limitations to this approach?
Yeah, that's a good question.
Like, are there certain tasks where NLRL might not be as effective?
I think so, yeah. So while it holds immense promise, it's still a relatively new field,
Yeah.
and there are definitely some limitations.
Can you give me some examples?
Yeah. So one challenge is dealing with environments that have continuous action spaces or really high dimensional states.
Okay.
So NLRL currently works best in environments where those actions and states can be pretty easily represented using language.
So if we're talking about controlling a robot arm with dozens of joints and sensors, NLRL might not be the best tool for that.
Right. Yeah. In those cases, traditional RL methods that work with numbers might still be more effective.
Okay, that makes sense.
Yeah.
What about any other limitations? Like, are there any other challenges that we should kind of be aware of as this field develops?
Yeah. Another challenge is just the computational cost of using these large language models.
Right.
So LLMs require a lot of computing power, especially those really massive models
Yeah.
that are capable of the most impressive feats.
Hmm.
So there's this trade-off between the power and flexibility of NLRL and then these practical considerations of how much computing power do we have? How efficient can we make these models?
Yeah, that makes sense. But I imagine, like, as technology continues to advance, those limitations are probably going to become less of an issue.
I think so, yeah. I mean, as LLMs become more efficient and we develop new techniques for training them, we'll be able to overcome those limitations.
That's good to know. Okay, so where do we go from here? Like, what are the most exciting directions for future research in NLRL?
Yeah, I think one area that's ripe for exploration is developing more robust and scalable methods for actually training these LLMs.
Okay.
So, we talked about things like prompting and this language-based Monte Carlo learning,
Right.
but there's still a lot of room for improvement in terms of, how efficient can we make this training? How stable can we make it? How well can these models generalize to new situations?
So we're still kind of in the early stages of figuring out how to like best harness the power of LLMs
Yeah,
for
exactly.
reinforcement learning.
Yeah, but I think the potential is really huge.
Yeah.
Imagine if we could develop NLRL systems that can learn from the vast amounts of text data that are available online.
Yeah.
They could adapt to new situations, solve problems that we previously thought were way too complex for AI.
Okay. So that is like a game changer.
I think so, yeah.
What about like specific applications? Like
Yeah.
where do you see NLRL having the biggest like real world impact down the road?
Yeah, so we've talked about education, we've talked about healthcare, but I think it could also revolutionize fields like robotics,
Okay.
customer service, even the creative arts.
Oh, wow.
So, imagine robots that can learn new tasks by following natural language instructions, or chatbots that can understand really complex customer requests and provide, much more personalized support.
So those like clunky chatbots that we all like dread talking to.
Exactly. We can say goodbye to those. And then, even AI systems that can compose music,
Oh, cool.
write stories, generate art based on these language prompts.
Okay, now you're really getting me excited about the future.
It is pretty exciting, I think.
It sounds like NLRL could usher in this like whole new era of like human AI collaboration
Oh, right. Yeah.
where we're like really working together,
Yeah.
combining our unique strengths
Yeah.
to solve problems, create like a better future for everyone.
Exactly. I think that's the potential.
But I also want to, we can't just get lost in all the
We're
excitement.
right.
We have to acknowledge that there are like potential downsides to a technology this powerful. Like we touched on this briefly before, but I think it's important to like really consider the ethical implications as well.
Absolutely. I think, as with any powerful technology, we need to be really mindful of potential risks and make sure that it's developed and used responsibly.
Definitely.
I think it's crucial that we have these open and honest conversations about the ethical implications
Yeah.
and that we establish clear guidelines and regulations as this technology continues to advance.
I completely agree. Like, it's about making sure that we're building a future where AI is like a force for good in the world.
Exactly. And it's not just about preventing negative outcomes.
Right.
It's about actively shaping AI development
Yeah.
so that it benefits all of humanity.
Yeah.
And I think NLRL has the potential to do that, to create AI systems that are more understandable, more collaborative, and more aligned with, our goals and values.
That's a vision worth striving for. Okay, so I think we've covered a lot of ground in this second part of our deep dive.
We have.
We've really got into the nuts and bolts of how NLRL works.
Yeah.
And I think in the next part, we should wrap things up with like taking a look at some of the most like thought-provoking questions
Yeah,
that this research raises about like the future of AI and like our relationship with technology.
absolutely.
Stay tuned for that. So welcome back. We've been on this incredible journey exploring natural language reinforcement learning.
We have.
It's wild, right? Like from how it actually works to how it can totally revolutionize like so many fields.
Yeah, I mean, we've talked about everything from AI tutors that can adapt to how each person learns,
Right.
to AI assistants that can help us with our busy lives, even AI collaborators in creative fields. It's pretty crazy to think about all that's possible when we bridge the gap between language and learning in AI.
It really is. I mean, this whole idea of like AI that can understand us
Yeah,
on that level is
it's mind-blowing.
it's mind-blowing. But as we wrap up here, I
Yeah.
kind of want to step back
Yeah.
and think about like the bigger questions that this research raises, NLRL has a lot of people talking, and for good reason, I think.
Yeah, definitely. And I think it sparked some really interesting debates about where AI is headed.
Yeah.
And one question that keeps coming up is NLRL just the beginning?
Yeah.
Are we seeing the start of a much bigger shift in how we think about AI?
Right. Like, what if we're actually on the verge of AI that can learn and reason a lot more like us, using language as its primary tool?
It's a really interesting question to consider. How would that change our relationship with technology?
Yeah. Like, would we start to see AI as more of a partner, a collaborator,
Right, instead of just a tool.
instead of just a tool?
Yeah.
Yeah. And that's like, that brings up all sorts of questions like philosophical questions, societal questions.
Sure.
Like, we might need to actually, like, rethink our definitions of intelligence,
Yeah.
consciousness. I
Totally.
mean, what it means to be human.
Yeah, where do those lines blur?
Yeah, it's like NLRL is forcing us to confront these, like, really fundamental questions about who we are and,
Yeah.
like, our place in a world that's increasingly populated by intelligent machines, which is like, whoa.
It's a big question.
Yeah.
And I think it's one that we need to start grappling with now.
Absolutely. And it's not just, like, philosophical. There are, like, very real practical implications, too, right?
Totally.
Like, if we have AI that can understand and generate human language on, like, a really sophisticated level, I mean, how is that going to change how we work, how we communicate, even how we think?
Right. Yeah, I mean, I think, for one thing, we can say goodbye to all those frustrating customer service chatbots.
Yes.
But beyond that, imagine the potential for collaboration. NLRL could break down the barriers between humans and machines, allowing us to actually work together on a much deeper level.
Right. Like, I can imagine working on a project
Yeah.
with an AI teammate
Yeah,
that can not only process data, but, like, actually brainstorm ideas with me,
totally.
help me come up with solutions, like, even help me write the final report.
Yeah, it goes beyond just work, too. Imagine having an AI assistant that really gets you,
Yeah.
understands your needs, your preferences, your goals.
Like my AI therapist.
Right. I mean, it could help you manage your time better. It could personalize your learning. It could even help you make better decisions.
So it's like NLRL could really open the door to this new era of like human AI partnership where we
Yeah.
combine our strengths
What's that,
to solve these complex problems and like build a better future.
I love that. I think that's really the ultimate goal.
Yeah, but I think, as we get excited about all this, we also have to remember the responsibility that comes with this kind of power, right?
Absolutely. And I think, looping back to what we were discussing earlier, the ethical considerations are paramount here.
Yeah, like developing and using NLRL ethically is, like, so crucial.
It really
Like,
is.
we need to keep having these conversations.
Mhm.
We need clear guidelines, responsible development practices. Like, this
Yeah.
technology has the power to, like, totally reshape the world, and it's up to all of us to make sure it's for the better.
I couldn't agree more. I think this research is really just the beginning.
Yeah.
NLRL is a rapidly evolving field with so much potential.
So much potential.
And I think, it's up to us to explore that potential responsibly and ethically.
Absolutely. Well, I think we've given everyone a lot to think about today.
We have.
And we've only just scratched the surface, right?
Totally.
There's so much more to learn and explore.
Yeah, keep diving in.
So keep diving in, and for those who want to learn more, we've got links to the research paper and other resources in the show notes.
Definitely check those out.
And until next time, keep exploring the amazing world of AI. It's a wild ride.